We have four graphs here, and what I want to do is talk about them and how we can write the inequalities for them. So a couple of things. If you have an open circle, like we have an open circle here on 3, and we have an open circle here like on negative 34, okay? If that happens, what that means, an open circle is every number on the line, so every number on shaded line except for the circle is a solution. Okay, so for the closed circle, the circle is part of the solution. Okay, so what I mean by that, as we look at this, all right, this left-hand side here is shaded. So all these numbers are solutions, but number 3 here, which is part of my solution, my arrow here, all right, this 3 is not part of the solution, but it could be like 2.999999999. So we leave it open to show, you know what, we are going all the way up to 3, but we're not including 3 in the solution. Okay, now this arrow here is to the left. Okay, and what that means is that if I have some number x, okay, it has to be less than my circle 3. Now notice for the open circle, all right, I'm making this less and not less than or equal to. So this is going to be less than or greater than, okay? Over here for the closed circle, it's less than or equal to or greater than or equal to. So what we do when we're writing the inequality, if it's an open circle, we are not going to include the extra line underneath, because the extra line underneath is part of an equal sign. So when we read this, we're like less than or equal to. Well, this is just less than 3. This is not equal to 3 because it's not filled in. Okay, so here we're going to have x less than 3. Okay, so this is the answer to this one. So let's go ahead, and I guess I don't want this here. So this would be x less than some number. And if we have an arrow to the right, we'll hit that when we get down here. So taking a look then for our next problem here, it says, well, what numbers are solutions to this? All right, now I can tell you, we can have the number -5, -4, -3. We should be able to, if it's a solution, we can come up. So -3, yep, that's on my line. It's a point except on my line, so I circle that. 0, so I look at 0, and sure enough, it's in the shaded part of my line. So yes, that is a solution. Okay, 3 is part of my ray to the left here, right? So that's part of it, but I can't include 3 because it's not equal to. It's everything up to 3, but not including it. Okay, so 3 is not a solution, and 5 is not on my shaded line, so that's not a solution. So for our next problem, we take a look here, and it looks like we're going by 2. So 0, 2, 4, 6, 8, 10, 12, 14, and this number is 16. So I know I'm dealing with 16. Okay. Now my arrow is to the left. Okay, so if I have that, that means everything to the left is a solution, which means all my x values can go all the way up to this 16. So it's going to be less than or equal to 16. Okay, so this is the first one. X is less than 3. And I do want you to write this because I have a feeling that some people you're not sure what the symbols are. So this is less than, and this is x is less than or equal to 3. Now this is important because even reading the symbol, it's less than or equal to this, or 16, sorry, 16. And that's important here because when we come to this next part, we're like, well, what numbers are solutions? So we take a look, and I have -10. Now this arrow stops at -2, but this arrow signifies that it's going to continue infinitely to the left. So everything to the left of this arrow is part of the shaded line. It just didn't go all that way. So this is all the solution. So -10 is a solution. Then we come up and we have -2 or +2. That is on the line. We come up to 14. That's on the line. 16, not labeled, but that's the point in the middle of 14 and 18. 16, it can be equal to. So realize if you're stating it correctly, x is less than or equal to 16. This is a solution. 18 is not part of our line, so that is not. And 22 is not on my answer solution, so it is not. Okay. So next, notice how I have an arrow going to the right. So what happens is I look for my initial point. So I'm looking for the point. I'm like, oh, okay, here it is at -34. Okay, so I have -30, -35, -40. So this is -34. If you said for some reason -33, that's fine. All right, so we have -34. And this time my arrow is pointing to the right, which means every x number has to be greater than this position here. So this is going to be x greater. Now I'm not putting greater than or equal to because it's an open circle. So an arrow to the right would be x is greater than a number. Or like I said, greater than or equal to, where this could also be less than some number. Okay. So let's go ahead and come to the solution. So what numbers are the solutions? So again, here's my line here, my ray. All right, the arrow is here, but remember that arrow means everything to the right is also solution. So as we come over here, I go to -40, and that is not on my graphical solution. Then I come to -34. Now -34 is an open circle, right? So x is greater than that, but it can't be equal to -34. We come to -20. That is a solution. 0 is 20. Yes, 20 was not in the solution that was drawn in this diagram, but because of that arrow, it is part of the solution. And then our last one for writing inequalities, we find our start point. All right, so I'm not looking at the arrow. I'm looking at the point we're starting at, and it's 3, so I can write that down. And we're going to the right, which means we're going to be using greater than. So this is x is greater than. For this one, I do need to include the 3 because it's equal to. Okay, so then what we have is our solutions. 0's right here. That is not a solution. It's not on my line. So my ray here goes to the right, and I know it's going to continue going because of this arrow. 3, it is a solution this time because it's a filled-in circle. 6 is on there, and 9, even though it wasn't part of the original solution drawn, because of the arrow, it's implying that it's going on infinitely forever, so that would be part of the solution. So the next part we want to do is drawing inequalities. Okay, so we take a look at our number first, and I have 2, and I know that it is a solid circle because of it, the equals 2. All right. So because we can equal the 2, I want to make sure that's part of my drawn solution. Now I need to draw a ray. This means x is greater than or equal to, so greater than or equal to 2. So if I'm looking for values greater than or equal to 2, that's got to be 3, 4, 5, 6, 7, 8, 9. So that's going to go this way when we draw the arrow. Now, if x is on the left, all right, so if x on left, you can draw in the arrow direction. And what that means is, does everybody see here how this kind of creates an arrow, like this symbol, the greater than or equal to, can kind of look like an arrow tip? Okay, we're going to draw in the direction of the arrow tip, but only if x is on the left. So you do have to be careful for that. So if you're not sure, you can always pick a number. So I can say, all right, 6. 6 is supposed to be a solution. I come over here. Is 6 greater than or equal to 2? Remember, this is like an alligator. It eats the bigger number. And yes, it's going to eat 6 because 6 is larger than 2. All right, -3. We're starting here. But now notice it's just less than. Okay, so not equal to. So this just is a less than. There's no equal to part on here, so I'm going to leave it open. Now again, if we're looking at the arrow is pointed left. Okay, so that's one way, and we can do that since x is on the left-hand side. The other thing we're going to make sure is if we have x less than -3, the alligator wants to eat the biggest number. So if the biggest number is -3, then every other number needs to be less than -3, which means it has to go to the left. You can plug in and check. Is -5 less than -3? Yes, it is. Now I have 8 less than or equal to x. So I come over here to 8, and I have an equal to on there, so I'm going to make it a solid circle. All right, now here, notice the alligator wants to eat x. That means x needs to be more than 8 because the alligator is eating more. Well, what numbers are more than 8? 9 and 10. So this is where it's going to go this way. And then you're like, wait, Mrs. Weber, the arrow is pointing to the left. It is pointed to the left, but x has to be on the left to use this trick. So here, I can flip. If I flip sides, then I also must flip the sign. And here, then, you can see how the arrow does point in that direction. So we go to the next one, and let's see. Let's have flip-flopping here. All right. So here, I have -5, and I have an open circle because of the less than sign. So -5. Okay. Now, the alligator, again, wants to eat x. Okay? Since the alligator is trying to eat x, that means x needs to be more than 5. And since x is my solution, it has to be all these numbers, right? So if we flip, am I saying that right? The alligator wants to be x, and it needs to be more than 5. Now, if we flip this, it's going to look like x greater than -5. Okay? So again, if you flip the two sides, you flip the arrow, you're good to go. So over here, we have everything shaded to the right, and that's where you could follow the arrow.